All right, welcome to the Explainer. So, let's just dive right into how the events of June 2026 completely shattered our traditional computing boundaries. For years, there was this growing, kind of uncomfortable feeling in the tech world that we were about to hit a brick wall. Traditional chip scaling was slowing down, power demands were going absolutely through the roof, and AI models, well, they were getting way too big for our current infrastructure to handle. So what happened in June 2026 wasn't just surprising. Honestly, it was inevitable. We are right in the middle of a massive, systemic realignment in technology, one that fundamentally changes how hardware and software actually interact. And it's all being driven by the relentless, insatiable demands of autonomous, agentic AI.
$60 billion. I mean, take a second to put that into perspective. That is the kind of money usually reserved for an entire nation's defense budget or, buying up massive legacy conglomerates. But instead, it's being dropped on a single piece of the AI puzzle. That staggering number is proof that we are smack in the middle of this systemic realignment. It's the literal price tag for a deal we're going to look at in just a moment. A deal where the tech industry is frantically redesigning silicon, restructuring data centers, and literally rethinking the laws of physics themselves, all just to keep up with the pace of innovation.
Here's our agenda for today. 1. Nvidia reinventing the PC. 2. Intel's agentic counterattack. 3. SpaceX's massive cursor acquisition. 4. The commercial quantum leap. And 5. The future of computing. Let's get into it.
Section 1. Nvidia reinventing the PC. Now this is where Nvidia is pulling off an absolute masterstroke. You know that legendary CUDA soft remote everyone talks about? Well, they're digging it even deeper, and they are trapping the entire developer ecosystem inside this inescapable walled garden. Nvidia partnered with MediaTek to build the RTX Spark, which is honestly the first full reinvention of the laptop in 40 years. We're talking about a 20-core Grace ARM CPU paired with a Blackwell GPU packing over 6,000 CUDA cores. But here's the genius part. By packing this Blackwell GPU and 128 gigabytes of unified memory into a localized edge device, they are extending their impenetrable CUDA software moat straight to your desktop. You don't need to rely on the cloud to build complex 120 billion parameter agentic workflows anymore. You don't need a massive server rack. You just need Nvidia. This is highly calculated to keep developers locked into the CUDA architecture from the ground up, guaranteeing Nvidia's absolute dominance at the edge.
But hey, think about what giving an AI agency actually means in the real world. For an AI to truly act as your agent, it needs unrestricted access to your life, right? Your personal emails, banking credentials, private files, conversations, the whole shebang. You absolutely cannot send that kind of sensitive data to a random remote server sitting in the desert. Enter OpenShell. It perfectly solves this massive privacy bottleneck. Built by Microsoft and Nvidia natively for the Surface Laptop Ultra, OpenShell acts as an OS-enforced containment layer right on your device. It filters and sanitizes your data locally, ensuring your AI agents can run securely and privately. It basically gives your autonomous agent the ultimate security clearance it needs to take actions on your behalf, without ever compromising your privacy.
Section 2. Intel's agentic counterattack.
So, the whole computing paradigm is violently shifting right beneath our feet. During the initial AI training boom over the last few years, the industry basically threw GPUs at absolutely everything. In data centers, GPUs heavily outnumbered CPUs, often by a 4-to-1 ratio, because training large language models requires massive parallel processing. But inference, actually running these complex, autonomous AI agents in real-time production, totally different beast. It requires incredible amounts of logic, decision trees, and sequential processing. Suddenly, the forgotten CPU is the bottleneck. The industry is being forced back into a much more balanced 1-to-1 ratio between the CPU and GPU just to keep these autonomous agents running smoothly. And to capitalize on this shifting balance of power, Intel just rolled out their new Xeon 6 Plus processors, packing a staggering 288 cores built on their 18A process. They're deploying this insane computing power through massive rack-scale partnerships, like the recent integration with Samba Systems. And the goal here isn't just about selling a processor anymore. They are building highly dense, scale-out infrastructure specifically designed for what we call disaggregated inference, which basically means they can take these incredibly complex AI workloads, break them apart, and process them seamlessly and affordably across entire racks of servers. Intel knows the future isn't just about training a few giant models. It's about running millions of autonomous agents simultaneously without breaking the bank.
Section 3. SpaceX's massive cursor acquisition.
Okay, to truly understand the gravity of the SpaceX acquisition, you really have to look at Cursor's terrifying momentum. From the moment they launched, it took them less than 2 years to reach $1 million in annual recurring revenue. Today, they're sitting at $200 million in ARR, and they are actively utilized by 67% of Fortune 500 enterprise development teams. Let me be super clear about this. They are the fastest-growing SaaS product in the history of software. Period. So the obvious question is, why on earth would a company with that kind of meteoric, unprecedented trajectory agree to sell for $60 billion?
Well, the answer really boils down to two things: raw ambition and hard physical limits. Cursor realized that as long as they were just an API wrapper, essentially piggybacking on models owned by OpenAI or Anthropic, they'd always be restricted by someone else's infrastructure. And they don't just want to build an AI that auto-completes your code. No way. They want to build the ultimate autonomous agent that actively engineers and deploys entire software systems while you sleep. To achieve that level of deep hardware integration, you need raw metal. You need brute force. And SpaceX and xAI possess exactly that hardware. By joining forces, senior Cursor engineers have already transitioned to report directly to Elon Musk, facilitating the deep, native integration required to actually build the ultimate agentic AI.
And the hardware they are getting access to? It's called Colossus 2. Through the xAI integration, Cursor is essentially being handed the keys to a supercluster boasting 550,000 active graphics processors. That delivers a training and inference capacity equivalent to 1 million H100 GPUs. Let's just emphasize the absurdity of that scale for a second. Just a couple of years ago, a cluster of 10,000 GPUs was considered world-class and practically unattainable for most startups. Now we are talking about 1 million. This gives Cursor the literal infinite compute they crave to push agentic AI vastly past human-level development capabilities.
Section 4. The Commercial Quantum Leap.
Because here's the harsh reality. AI and these massive data workloads are pushing our current silicon to the absolute brink. Classical computing is fast approaching structural limitations in energy consumption, memory scaling, and interconnect bandwidth. We are simply running out of physical space and power to make traditional chips faster. To give you a vivid example of how severe this is, tech giants are literally currently looking into contracting dedicated nuclear reactors just to keep their data center lights on and the chips cool enough to function. So, when classical computing hits that absolute physical wall, where do we go next? The answer isn't just squeezing out a smaller transistor anymore. The answer is quantum computing. It's an entirely new physical paradigm that fundamentally changes how computations are performed at the subatomic level. And listen, this is no longer just an academic pursuit locked away in some university basement. Quantum is the necessary next step to take the most complex, structurally impossible problems that would take our most advanced classical supercomputers 10,000 years to solve, and absolutely crush them in a fraction of the time. Companies like Quantinuum aren't just theoretically testing this anymore, they're actively bypassing classical limitations using full-stack architectures. Instead of chasing useless raw speed metrics, Quantinuum is prioritizing accuracy and system-level performance using their QCCD architecture. But what is really vital here is their focus on middleware. That's essentially the translation layer that allows traditional developers to actually write and deploy quantum code without needing a PhD in quantum physics. By building these domain-specific libraries and maintaining compatibility with established ecosystems like Nvidia's CUDA, they are accelerating developer workflows and making quantum commercially useful, like right now.
Plus, the federal government clearly sees this massive computational wall approaching, and they realize this isn't just corporate R&D anymore. This is a full-blown federal arms race. The CHIPS and Science Act recently proposed massive funding, including $1 billion to IBM to build a U.S. quantum wafer manufacturing foundry and another $375 million to global foundries. The United States government recognizes that whoever owns the quantum foundries fundamentally owns the future of global tech supremacy and national security.
And over in the enterprise space, IBM is taking this just as seriously, throwing $10 billion of its own money at this technology. They're targeting a major milestone called quantum startling by 2029. It's crucial to understand that 2029 is not some distant sci-fi future. That is just around the corner. IBM is betting $10 billion that in a matter of a few years, commercial quantum computing will be a strategic reality that will redefine artificial intelligence all over again.
Finally, Section 5, the future of computing. All right, so let's bring this all together. The crucial takeaway from today's explainer is that computing is rapidly branching into 3 totally distinct but deeply interconnected extremes. You have hyper-powered edge devices locking you into incredibly sophisticated software modes, like Nvidia's CUDA, right on your desk. You have massive, centralized megaclusters wielding millions of GPUs to power infinite compute agents, and you have the dawn of commercial quantum foundries breaking straight through the barriers of classical physics. These aren't competing technologies, guys. They form a brand new ecosystem. Your edge devices will communicate with megaclusters, which will in turn offload the most impossible problems to quantum foundries.
Which leaves us with this final, kind of wild thought for today's explainer. We are currently redesigning the entire global computing infrastructure specifically to support machines that act on their own. If these newly unleashed AI agents are out there taking real-world actions, utilizing megaclusters and quantum physics to do it, what's actually left for us to do? Are we still the operators of technology, or are we about to become its middle management? Let me know what you think about all this, and I'll catch you in the next explainer.